Welcome to the WWC RDD Standards Training module focused on continuity of the relationship between the outcome and the forcing variable. You can access all the resources mentioned in this module through the WWC website, whatworks.ed.gov. This module describes the WWC's third RDD standard, often called the continuity standard, which outlines requirements for RDDs to establish continuity of the relationship between the outcome and the forcing variable used in the design. This module introduces the concept of the continuity in the outcome forcing variable relationship, and then describes how the WWC assesses such continuity in RDD studies. After completing this module, you will be able to define what is meant by continuity in the outcome forcing variable relationship in an RDD, and why the WWC is concerned about that continuity. You will be able to describe the WWC's continuity standard and will know how to apply that standard when conducting a WWC review of an RDD study. The WWC's continuity standard focuses on the concept of continuity or smoothness in the relationship between the outcome and forcing variable at the cutoff used in an RDD. The WWC's focus on continuity is due to the concern that something other than the intervention could be responsible for the intervention impact observed at the cutoff. To obtain a consistent impact estimate at the cutoff using an RDD, there must be evidence that in the absence of the intervention, there would be a smooth relationship between the outcome and the forcing variable at the cutoff. This smoothness condition is required to ensure that any observed discontinuity in the outcomes of intervention and comparison group units at the cutoff can be attributed solely to the intervention. This smoothness condition cannot be assessed directly. The WWC instead uses indirect approaches to assess for continuity. As shown in this table from the WWC Standards Handbook, to completely satisfy the continuity standard, the regression discontinuity design must satisfy three criteria. First, baseline equivalence must be established on key covariates. Second, there must be no graphical evidence of extra discontinuities in the outcome forcing variable relationship. And third, there must be no statistical evidence of extra discontinuities in the outcome forcing variable relationship. To partially satisfy the continuity standard, an RDD study must establish baseline equivalence on key covariates and satisfy at least one of the criteria related to graphical or statistical evidence. And if an RDD study does not satisfy the criteria in these ways, the study does not satisfy the continuity standard. We will now describe each of these three criteria in greater detail. Criterion A of the continuity standard requires that baseline equivalence be established for all key covariates at the cutoff value of the forcing variable. Key covariates here refer to those covariates identified in the review protocol for which baseline equivalence must be established. Criterion A reflects an indirect approach for assessing the smoothness assumption of the outcome forcing variable relationship at the cutoff. The logic of this criterion is to test whether, conditional on the forcing variable, key baseline covariates presumed to be correlated with the outcome are indeed continuous at the cutoff. This means that the intervention must have no impact on baseline covariates at the cutoff. Applying Criterion A to assess baseline equivalence requires calculating an impact at the cutoff for each covariate of interest. For these baseline equivalence calculations, the study must either use exactly the same bandwidth and/or functional form as was used to estimate the impact on the outcome, or the study must use the same algorithm for selecting the bandwidth and/or functional form as was used to estimate the impact on the outcome. These baseline equivalence estimates can then be assessed using the baseline equivalence standards for group designs, and is covered in more detail in Module 3 of the Group Design Standards training. If the impact for any covariate is greater than 0.25 standard deviations, Criterion A is not satisfied. If the impact for a covariate is between 0.05 and 0.25 standard deviations, the statistical model used to estimate the average treatment effect on the outcome must include a statistical adjustment for that covariate in order to satisfy criterion A. And finally, any baseline equivalence impacts for a covariate less than or equal to 0.05 require no statistical adjustments. If an RDD study does not satisfy the attrition standard, then baseline equivalence must be established using the exact same analytical sample as used in the outcome analysis. In other words, the baseline equivalence calculations must be conducted using only participants with non-missing values on the outcome variable used in the final impact analyses. Exogenous exclusions from the sample are still allowed. Conversely, if a study partially or completely satisfies the attrition standard, then baseline equivalence may be demonstrated using data not in the analytical sample, such as data from a different year, cohort, or site. The review team leadership, in consultation with content experts, has discretion to determine whether the sample is too different from the context in the study sample to satisfy this criterion. Criterion B of the continuity standard requires that there be no evidence using graphical analyses of a discontinuity in the outcome forcing variable relationship at values of the forcing variable other than the cutoff value, unless a satisfactory explanation of such a discontinuity is provided. This criterion is another indirect approach for assessing the smoothness assumption of the outcome forcing variable relationship at the cutoff. The graphical analysis to support criterion B would typically entail a scatter plot of the outcome and forcing variable, using either the raw data or data averaged and aggregated within bins or intervals. To satisfy criterion B, this graphical analysis must not show a discontinuity in any forcing variable value within the bandwidth that is larger than 2 times the standard error of the impact estimated at the cutoff, unless a satisfactory explanation of that discontinuity is provided. When the authors are estimating impacts within a bandwidth, the goal is to look for egregious changes in the slope that may indicate some event other than the intervention that may be changing the relationship between the outcome and the forcing variable. In the event that a bandwidth is not used for the analysis, then the graphical analysis must not show discontinuity in any forcing variable value, unless a satisfactory explanation of that discontinuity is reported. An example of a satisfactory explanation for an observed discontinuity might be when the discontinuity corresponds to some other known intervention that was also administered using the same forcing variable but a different cutoff value. If you are uncertain about any graphical display, you should raise your questions with review team leadership. Here is an example graph from a hypothetical RDD displaying the association between the forcing variable on the x-axis and the outcome variable on the y-axis. In this example, the cutoff score of 50 on the forcing variable is used to assign participants to conditions, with those scoring at or below the cutoff being assigned to the intervention group, and those scoring above the cutoff being assigned to the comparison group. This scatter plot provides graphical evidence to support criterion B of the continuity standard. This is because there's no evidence in this graph of a discontinuity in the outcome forcing variable relationship at values of the forcing variable other than the cutoff value. In this example, there is a clear discontinuity in the outcome forcing variable relationship at the cutoff value of 50. However, there are no other discontinuities observed at any other values of the forcing variable. Conversely, this scatter plot would not provide graphical evidence to support criterion B of the continuity standard because there is graphical evidence of a discontinuity in the outcome forcing variable relationship at values of the forcing variable other than the cutoff value. Although we still observe a discontinuity in the outcome forcing variable relationship at the cutoff value of 50, there is now also a clear discontinuity observed at the value of 55 on the forcing variable. In this example, if that discontinuity observed at the value of 55 of the forcing variable was larger than 2 times the standard error of the intervention impact estimated at the cutoff, And if the authors do not provide a satisfactory explanation of this discontinuity, then such a study would not satisfy criterion B of the continuity standard. Criterion C of the continuity standard requires that there be no evidence using statistical tests of a discontinuity in the outcome forcing variable relationship at values of the forcing variable other than that at the cutoff value, unless, of course, a satisfactory explanation of such a discontinuity is provided. The statistical tests used for criterion C must use the same algorithm for selecting the bandwidth and/or functional form as was used to estimate the impact on the outcome. Furthermore, these statistical tests must be conducted for at least 4 values of the forcing variable below the cutoff and 4 values above the cutoff, and at least 95% of the estimated impacts on the outcome at other values of the forcing variable must not be statistically significant at the 5% significance level. This requirement accounts for expectations that some estimates may be statistically significant simply due to type 1 error. If these impacts are estimated for fewer than 20 values of the forcing variable, then all of them must not be statistically significant at the 5% significance level. It's time now for your first knowledge check in this module. An RDD study examined the impact of a school's assessment-based promotion policy on high school seniors' science achievement. The review protocol requires baseline equivalence for pretest measures of the outcome. The baseline equivalence effect size at the cutoff value for the pretest measure is calculated as 0.20 standard deviations. This baseline equivalence effect size was estimated using a bandwidth of 0.15 that was selected using cross-validation. The regression model used to estimate final impacts included the pretest measure as a covariate and was estimated using a bandwidth of 0.5 that was selected using cross-validation. Does this study satisfy criterion A of the continuity standard? Your choices are A, yes, B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, criterion A of the continuity standard is satisfied because the study reported baseline equivalence on the required covariate at the cutoff, namely the pretest measure, and they did so using the same cross-validation algorithm for selecting the bandwidth as was used to estimate the impact on the outcome, and because this pretest variable with a baseline equivalence impact of 0.20 standard deviations was included as a covariate in the model used to estimate the impact on the outcome. Thus, this study would satisfy criterion A of the continuity standard. It's time for knowledge check number 2. An RDD study presents the graph shown on the next slide. Based on this graph, does this study satisfy criterion B of the continuity standard? Your choices are A, yes, B, no. In this graph, the dark shaded region that surrounds the best fit curve represents the 95% confidence interval for the best fit curve. The lighter gray shaded region between the dotted lines represents the bandwidth. The solid vertical line represents the cutoff score on the forcing variable, and the distance between the dashed horizontal lines equals 2 times the standard error of the intervention impact estimate. Again, based on this graph, does the study satisfy criterion B of the continuity standard? Your choices are A, yes, B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the graph provided, criterion B of the continuity standard is satisfied because the scatter plot of the outcome enforcing variable does not show a discontinuity at any forcing variable value within the bandwidth that is larger than 2 times the standard error of the impact estimated at the cutoff. Thus, the study provides graphical evidence of continuity in the outcome forcing variable relationship. Another knowledge check, this time number 3. A regression discontinuity study reported an impact on the outcome of 0.10 based on a quadratic regression selected using the Bayesian Information Criterion, or BIC, goodness of fit measure. The authors conducted sensitivity analyses by calculating discontinuities in the outcome at 26 values of the forcing variable other than the actual cutoff, all based on linear, quadratic, and/or cubic regressions selected using the BIC criterion. Half of the values were above and half of the values were below the cutoff. The values were evenly spaced across the distribution of the forcing variable. One of those discontinuities was statistically significant at the 5% level. Does this study satisfy the RDD Standard 3, Criterion C for statistical continuity? Your choices are A, yes, B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, Criterion C of the RDD Standard 3 is satisfied because the statistical tests used to assess continuity use the same BIC algorithm for selecting the functional form as was used to estimate the impact on the outcome. And these statistical tests were conducted for at least 4 values of the forcing variable below the cutoff and 4 values above the cutoff. And finally, because at least 95%, or 25 out of 26 of those impacts, were not statistically significant. Thus, this study would satisfy Criterion C of the continuity standard. Finally, knowledge check number 4. An RDD study examined the impact of a bilingual education program on English learners' language proficiency outcomes. The study satisfies Criterion A, baseline equivalence, and Criterion B, graphical evidence of continuity, of the continuity standard. However, the authors did not report any statistical evidence regarding continuity in the outcome forcing variable relationship. For the continuity standard, or the RDD Standard 3, does this study A, completely satisfy the standard, B, partially satisfy the standard, C, does not satisfy the standard? You may want to pause the video now to think about your answer. The correct answer is B. To partially satisfy the continuity standard, the study must satisfy Criterion A while also satisfying either Criterion B or Criterion C. Because the study satisfies both Criterion A and B, the study partially satisfies the continuity standard. This concludes our module on the WWC's continuity standard. Let's review what we discussed in this module. We described the 3 criteria used to assess the continuity standard. To completely satisfy the continuity standard, an RDD study must satisfy each of criteria A, B, and C, establishing baseline equivalence, graphical evidence of continuity, and statistical evidence of continuity of the outcome forcing variable relationship. To partially satisfy the continuity standard, an RDD study must satisfy Criterion A and must satisfy either Criterion B or Criterion C. In all other cases, an RDD would not satisfy the continuity standard.
Recall that there are 5 total standards which determine a study's overall rating. You are now familiar with 3 of those 5 standards. For a study to receive a rating of meets WWC RDD standards without reservations, a study must completely satisfy the continuity standard. For a study to receive a rating of meets WWC RDD standards with reservations, a study must partially satisfy either the attrition standard or the continuity standard. A study that fails to at least partially satisfy either of those 2 standards will receive a rating of does not meet WWC RDD standards. The next module in the training series will focus on the 4th RDD standard, which outlines requirements for appropriate functional form and bandwidth specification in RDD studies.